The objective of this lesson is to subtract fractions with related denominators by creating equivalent fractions with common denominators. In previous lessons, students have subtracted fractions with like and unlike denominators using models as well as the common denominator strategy. However, in previous lessons, students subtracted fractions where the minuend and subtrahend were known. Today, the students will have problems that either have the minuend or subtrahend unknown. In previous lessons, students also learned that the subtrahend can be found by taking the difference away from the minuend, and the minuend can be found by adding the difference to the subtrahend. This lesson is intended to move away from the use of manipulatives, but students may still need them. Let's begin with our first problem. Before breakfast, a bowl had 5/8 of a cup of butter. After breakfast, there was 2/8 of a cup left. How much butter was used during breakfast? The equation to represent this problem would be the 5/8 butter subtract A, an unknown amount, equals 2/8 left. Let's draw a model of the problem. Start by drawing a rectangle. The problem states there was 5/8 butter to start with. This will be represented by dividing the rectangle into eighths and shading in 5 parts. Cross out the rest of the pieces of the whole that will not be used in this model. In order to find the amount that was subtracted, or the subtrahend, take away the amount that was left, or the difference. Shade in 2 of the eighths using another color to show the amount that was left. There are 3 of the eighths remaining. This shows that the portion that was used during breakfast, 3/8 of the butter, was used. Let's try another problem. There is 9/10 of a kilometer between Bianca's house and the school she attends. Bianca has 2/5 of a kilometer left to walk before she gets to school. How far has she already walked? The equation to represent this problem would be the 9/10 kilometer between her house and the school, subtract the kilometers walked, m, equals 2/5 kilometer left to walk. The first step is to create common denominators. The denominators 10 and 5 are related. 10 is 2 times 5, or 5 times 2 equals 10. Multiply the 2/5 numerator and denominator by 2 for an equivalent fraction of 4/10. Rewrite the equivalent equation. 9/10 subtract m equals 4/10. m equals 5/10. Bianca has 5/10 of a kilometer left to walk, or 1/2 kilometer. In both problems, the subtrahend was unknown. Let's try solving a problem where the minuend is unknown. There was some butter in the bowl. During breakfast, 5/8 of a cup was used. After breakfast, there was 1/4 of a cup remaining. How much butter was there to begin with? The equation to represent the problem will be total butter, T, subtract the 5/8 used, equals the 1/4 cup left. Let's use fraction circles to help solve. Start with 2 circles. The first circle will represent the amount of butter that was used, 5/8. Divide the circle into eighths and shade in 5 portions. Write 5/8 below the circle. The second circle will represent the 1/4 still left. Divide the second circle into 4 pieces and shade in 1 part. Write 1/4 below the circle. The denominators need to be the same in order to solve. 1 of the 4th sized pieces is equal to 2 of the 8th sized pieces. 1/4 is equivalent to 2/8. The equivalent equation is T subtract 5/8 equals 2/8. The answer is found by combining or adding the two amounts. 5/8 plus 2/8 equals 7/8. There was 7/8 cup of butter to start with. Let's solve the same problem numerically. The denominators are related. 8 is 2 times 4. 1/4 can be changed into a common denominator of eighths by multiplying by 2. The equivalent fraction to 1/4 is 2/8. T subtract 5/8 equals 2/8. In order to solve, add the difference to the subtrahend. 2/8 plus 5/8 equals T. T equals 7/8 cup of butter. The objective for this lesson was to subtract fractions with related denominators by creating equivalent fractions with common denominators. We met this objective by using area models along with fraction circles to model the subtraction of fractions with unlike denominators. We also used the common denominator strategy to solve numerically.